Okay. So 7.2c, so what is the mean of the sampling distribution of p hat? So the mean of p hat equals p, which equals, or a better one would be 1/3. Because 1/3 is a better answer than 0.3333, you know.
Wait, really?
Yes.
Oh, okay.
Yes, it is. Especially because you have a calculator so you can do it. You guys remember, every time you round, you're creating round off error. So if at all possible, try not to round until the very end. Okay? Okay, it says, what is the standard deviation of the sampling distribution of p hat? So what is p? 1/3. What is, oh man. What is, that is 1/3, you guys, bless you. What is 1 minus p? And what is our sample size? And people at home can't see that. There you go. So it's 1/3 times 2/3 divided by 60. You guys, again, 1/3 is a much, especially because it's a repeating decimal. If you can, you don't want to round to the very end, okay? So you can do 1 divided by 3 times 2 divided by 3 divided by 60. And you should have gotten 0.0609. Is that what you guys got? There you go. Again, see, it's a much better, if you would have been close, but let's go out 4 decimal places. Now we've got a better answer. Okay, describe the shape of the sampling distribution of p hat. Justify your answer. So how do we prove normality in p's?
Is it NP is greater than or equal to 10, and n times 1 minus p is also greater than or equal to 10?
Yes. So when it comes to normality, this is how you prove it. CLT is used for means. So what is my n? 60. What is my p?
1/3.
So 60 times 1/3 is, so 60 is my n, 1/3 is my p, 1/3 of 60 is, and is 20 greater than or equal to 10?
Yes.
So that one works. Then 60 times what? 2/3. And what is 2/3 of 60? 40. Is 40 greater than or equal to 10?
Yes.
Yes. And then you have to write a sentence. You can't just, you have to say, describe the shape. The shape of the sampling distribution of p hat is approximately normal because the criteria of n times p greater than or equal to 10 and n times 1 minus p greater than or equal to 10 is true. Again, the shape of the sampling distribution of p hat is approximately normal because the criteria of n times, or the condition, it can be criteria or the condition of n times p being greater than or equal to 10 and n times 1 minus p is greater than or equal to 10 is true or has been met. Okay? And how do you know it's been met? Because you just proved it. Okay, so prove it, sentence. So is there any other question? Or you can say, since n times p is greater than 10 and n times 1 minus p is greater than or equal to 10, the shape of the distribution of p hat is approximately normal. Okay? Okay, you ready for D? What questions do you have over A, B, or C? Okay, D. Suppose that when you actually roll the die 60 times, you get 30 rolls of 1 or 2 for a p hat of 0.5. So now our p hat is what? 0.5 or 1/2. Are your suspicions about whether this die, okay, are you suspicious about whether the die is fair? Oh my goodness. Justify your answer. So now what we have to do, you guys, is we have to find that z-score. So we're trying to find the probability that p hat is greater than 0.5. So how do we do that? The first thing we're going to need to do is you probably should draw a picture. I'm not going to draw a picture right now, but you should have a picture here, okay? And the picture should be 1/3 is in the center, okay? Again, you guys, 1/3 is in the center, and then your standard deviation of that 0.069. Now we have to find the z-score. And the z-score would be 1/2 minus 1/3 over 0.0609. Okay. You guys, in your calculator, you can literally do 1/2 minus 1/3 divided by 0.0609 to get a z-score of 2.74. Now what do you have to do? You have to look it up in your chart. And then what did you get? So what is the area? It must have been big because you found it to the left and you have to subtract. So what was the area? Say it again. Okay, and so to find ours, you would do 1 minus 0.9969 because it's greater than, right? And then did you guys get 0.0031? So the probability that p hat is greater than 0.5 is 0.31%. So are you suspicious? Oh my gosh. Are you suspicious about whether the die is fair? Why are you suspicious that the die is fair? Yes, the probability of it happening is so unlikely that this die is probably not fair. You guys, if you had a high probability, then it was fair, but because you have a low probability, it's not fair.
How low does it have to be to justify fairness? Like, you got like 30%.
That's still kind of low. We'll talk more about like that p-values. We're getting towards those p-values, and they're going to tell us a lot more. Okay, did that help you guys? Okay, now, why can we use the standard deviation? Why can we use this standard deviation?
That's the distribution of normal.
No,
Oh, okay.
sorry.
No, it's okay.
Has something to do with,
Population is greater than 10 times the sample.
yes, the population of what, rolling the dice, right?
Yeah.
The population,
Rolls in existence.
yes,
Dice rolls.
yes.
Sure.
So is greater than or equal to 10 times 60, so 600. It's probably one of those that they probably wouldn't ask you about, but you have to know. Why can you use standard deviation? Because of the population size. You guys, to use standard deviation, it's always the population size. It's proving normality that is different. Normality is either n times p, n times 1 minus p, or CLT. And when do you use the CLT? For means. That only proves normality, nothing else. Okay, I want to go to 7.3b. I know we didn't get to this, but I'll do it and I'll upload it tonight so you can see it, okay? I promise. Someone should just message me sometime after 5 o'clock, because if you don't, I might forget, okay? But I promise you that if I will do it and I will get it up there for you so you can, you guys, it's not due until tonight at 11:59, okay? So 7.39, right? 7.39. 7.3b. That's, I don't know where I got 7.39 from. Okay. What is the mean of the sampling distribution? So what do we get? So the mean of X bar is 14,000, right? 14,000 miles? You guys, you can put miles on it. Do you have to? No. But when we get to chapter 11, we'll have to. Okay, the next thing is it possible to calculate the standard deviation of X bar? If it is, do the calculation. If it isn't, explain why. So is it possible to calculate the standard deviation of the of X bar?
Yes.
So what is the population of? Is the population of customers, right? Because there's customers, right? Has to be greater than or equal to what? 10 times, is it, how many people are in this?
Well,
So the population of customers greater than or equal to 12? I mean, to 120?
yeah, roughly.
Yes, we can assume so, yes. It's reasonable to assume this. Okay, if it's not reasonable to assume this, then no. But is it reasonable to assume that population? Yes. So how do you find the standard deviation of X bar?
1,045 square root of 12,
So what is sigma?
4,000.
4,000? And the sorry guys, it's the square root of 12, which gives you, oh, I'm so sorry you guys at home, I've been talking. So the population of customers is greater than or equal to 10 times 12. That's how you prove standard deviation. So what is 4,000 divided by the square root of 12?
4,154.7.
And we can leave it there. That's good. Now, do you know the approximate shape of this sampling distribution? Okay, so let's talk about it. This is a mean, so CLT. Can we use CLT to prove this is normality?
No, because, 12, the sample size of 12 is not large enough to apply CLT.
Right, so our sample size is not large enough, it's only 12, it is not, and it already told us, it didn't tell us, it told us the population was skewed to the right. Our sample size is not large enough, so no. Our sample size, we don't know, it's not approximately normal, okay?